Hello, grade 12. Okay, so today I'm just going to quickly go through trigonometric functions, right? The graphs of sine, cos, and tan. Okay, let's look at the first graph that I have here, which is the graph of f of x is equal to sine x. Now, there's just some basic properties that you need to know about each and every graph that we're going to do. Okay, so this is the graph of sine. So just always remember, sine of 0 is 0, sine of 90 is 1, sine of 180 is 0, sine of 270 is negative 1, sine of 360 is 0. Now, if you look at it, the graph has gone up and then gone down, and it's back to the same place. So the more we go along the x-axis, that graph is going to continue the same pattern. So the pattern repeats after 360. That is what we call the period. Okay, so the period of a sine function is 360, because that's where it starts repeating the same pattern over again. Same thing if you go the negative direction. So sine of negative 90 is negative 1, sine of negative 180 is 0, sine of negative 270 is positive 1, and sine of negative 360 is 0. So you see, you've gone back to the same pattern, and it's going to repeat itself again. So this pattern repeats itself after every 360 degrees. That is what is called the period. You will realize that your sine only goes up to 1 and then down again to negative 1 and then up again. That space of 1 is called the amplitude. Okay, the domain, remember what's the domain of a function? Any input value that you can put into the function is called a domain. All right, so the domain here is just x, which is any real number. The range, you can only get values between negative 1 and positive 1 in a sine function. Okay, the cos function is basically the same properties as the sine function, just some small differences. Like the cos of 0 is 1, so there's 1. The cos of 90 is 0. The cos of 180 is negative 1. The cos of 270 is 0. And the cos of 360 is positive 1. Okay, so you see, we started here, we went down, and we're back to the same place at 360. So what that means is that the cos function also has a period of 360. Okay, so the domain, any x value can be input in, and the range, the cos also has an amplitude of 1, just like the sine function, because you can't go more than 1. Okay, you can't go more than 1. All right, so that is the properties of the cos and sine. Okay, the tan function is kind of different, because if we look here at 0, right, remember the tan of 45 is 1. Okay, that's very important for you to remember. Tan of 45 is always 1, which means the tan of negative 45 is a negative 1. Okay, now why do we have a line at 90? That is called an asymptote, because if we try to find the tan of 90 degrees, make sure your calculator is in D mode. It's a math error, it's not possible. So that is an asymptote, obviously. So 90 degrees is an asymptote. Okay, what we can also see is that at 180 we're back to the same point. Okay, so what that means is that the period of a tan function is 180, because after 180 degrees we're back to the same place. Look here, it's going up and up and up towards the asymptote. Okay, and then we get to the asymptote, and then it goes from the negative again and passes through 180. Oh, we're back now. Okay, so the same pattern is going to repeat itself after every 180 degrees. So the domain is x any real value, but x cannot be equal to 90 plus k, where k is an integer. So every other multiple of 90 in with a periodicity of 180 cannot work, but you can get any number as the range of the tan function. Okay, right, here's an example. Okay, so sketched on the interval negative 90 to positive 180 are the graphs of a tan x and g of x is equal to sine bx. Okay, now obviously we need to find out what this a is and what that b is. Yes, you're asking how. That's what I'm going to show you. Okay, let's find the tan first. All right, so okay, this is number one. F of x is equal to a tan x. Now, what do we know about the tan graph? Well, what we know is that the tan of 45 is supposed to be 1, right? But now on this graph here, here's the tan of 45. It looks like a half to me. Yeah, it is a half actually. So what does that mean? That means a then is equal to a half. Okay, now the b. Right, now let's look at the graph of sine here. It's going up, then down, then back to the same place. Oh, but this is happening at 180, not 360. What does that mean? All right, so what that means is that to find k, we're going to take the normal period of a sine function, which is 360, divided by the period that we have here, which is 180, and dividing these will give us 2. So that means k is equal to 2. Well, sorry, instead of saying k, let me just say b. So therefore b is equal to 2. Okay, so our functions that we have now is f of x is going to be equal to a half times tan of x, and g of x is equal to sine of 2x. All right, what is the next question? Now we need to find out the coordinates of a and b. Okay, so basically we need to solve these two equations simultaneously. Now a is where the graphs are crossing each other, b is where the graphs are crossing each other. When do graphs cross each other? When the functions are equal, isn't it right? So they cross each other when what? When f of x is equal to g of x. Alright, so f of x, we know that to be a half times tan x, and g of x, which is equal to sine 2x. Okay, remember in the last video we were learning how to solve trigonometric equations. I hope you went through the exercises. So we're going to solve this equation, right? And we're going to solve it for x between negative 90 and positive 180. Why? Because that's what we have on our graph. Okay, right, so let's solve this. So first of all, I can multiply to both sides and have tan x equal to 2 sine 2x. Now we are going to apply our identities. So we know tan to be sine x over cos x, and we know sine 2x to be 2. Okay, so I'm going to multiply 2 sine x cos x. Okay, let's write this in a simpler form. So sine x over cos x is equal to 2 times 2, which is 4 sine x cos x. All right, maybe I can multiply both sides by cos x. multiply both sides by cos x, and we'll have sine x is equal to 4 sine x by cos squared x. Okay, let's divide both sides by sine x by sine x. Okay, they cancel, so that means 1 is equal to 4 cos squared x. Remember, in an equal sign we can put any other term on any other side of the equal sign. So just to make things easier, I'm gonna write my equation like that. Okay, so now I just divide both sides by 4, so that cos squared x is equal to 1 over 4. Take the square roots so that I find cos x on its own, and the square root of 1 over 4 is obviously 1 over 2. Okay, now I need to find my reference angle. So x is gonna be equal to the cos inverse of a half and x is going to be equal to, okay, so the cos inverse of a half is 60, which I think maybe some of you kind of picked it up from your you kind of picked it up from your special angles. Okay, right, this is the reference angle. Right, when is cos positive? Well, cos is positive all stations to Cape Town. Cos is positive in first quadrant theta and fourth quadrant 360 minus theta. Okay, the other solution will be x is equal to 360 degrees minus 60 from third quadrant, which is equal to 300 degrees. But note that we are only solving for x between negative 90 and 180, so this doesn't count anymore. Okay, so that means our x coordinate then is equal to 60. Right, obviously we need to find the y coordinate. So in order for us to find the y coordinate, we're going to go back to the question. Remember, this is a point on the graph of f, right, or the graph of g also. So just choose any of the two equations that you want to work with. Okay, I will choose g, right? So it's on the graph of g, remember, which is equal to sine 2x. So I'm just going to substitute 60 in there to find my y coordinate. So sine of 2 times 60 degrees, and on my calculator I found that to be square root 3 over 2. You can try that with a half tan x, you're going to get the same solution. So what that means is that the coordinate of b thereof is x being 60 degrees and y being square root of 3 over 2. Okay, while a is clear, it's 0 0. We can see that from the graph already, no need to work anything out there. So we're just gonna write 0 and 0, and those are the coordinates of b and a. Right, determine the minimum value of g of x minus 1. Okay, this minus 1, remember, it's a vertical shift downwards. The minimum value was negative 1 already, so if I move another one step down, that means the minimum value is now negative 2. So the minimum value will just be y is equal to negative 2. That's the answer. Determine the period of f of half x. Okay, the period of f of half x. Now if you want to find, if you've got a function, okay, f of half x is obviously equal to half tan of half x, right? Whenever you want to find the period of a function given this number here, which we normally call k, to find the new period, you're just going to take the period of the tan that we already know, which is 180, divided by that half, and the new period is going to be 360 degrees if you work it out from your calculator. Okay, it's an exercise that I've put on that lesson 7. Please try it and let me know if you're doing the work on the WhatsApp group chat. Thank you for watching.